Alright, so we've said irrational numbers are numbers that cannot be expressed in form of a over b, in form of a fraction. Now show that the following numbers are irrational. So let's have root 2. We want to show that root 2 is irrational. How can we show that? Now the first thing that you are going to do, you are going to use what we call an assumption method. You are going to assume that root 2 is irrational. Assume root 2 is rational. Now we know the meaning of a rational number. If root 2 is a rational number, then root 2 can be written in the form a over b. Okay, so that is what we know. Now remember, a and b are called coprimes. If you don't want to say coprimes, you can just say a and b are integers. Integers, we use the symbol z. Okay, a and b are integers, and b should never be equal to 0 because it is in the denominator. So this is the condition. Now what does it mean when you're talking about coprimes? So coprimes are numbers that cannot be divided by the same number. That is the condition that we take. So for example, 2 over 4, these are coprimes. That is because we've got a number that can go into 2 and 4 without leaving a remainder. So what we are saying is, in the simplest form of this fraction, there should never be a number that should go into both of them. And the simplest form of this fraction is going to give us 1 over 2. And for 1 over 2, there is no number that can go in both of them without a remainder. We are not including 1. So these are not coprimes. So I don't know an example of a coprime that I can give, but all we are talking about is these two numbers, they cannot be divided by the same number. So what I'm going to do is I'm going to square both sides. I'll square here. I'm also going to square here. So what are we going to get? We're going to get 2 being equal to a squared over b squared. Let's cross multiply. We're going to get a squared being equal to 2b squared. And you people, I think you know what this means. So if we say 2 is the same as 4 multiplied by half, what does this mean? This means that this 2 you are able to see here is able to go into 4. I hope we get that. So if there is a number that I can multiply with 4 for me to be able to get 2, then this 2 goes into what? Into 4. So if I say there's a number that I can multiply by 3 for me to be able to get 9, that means this 3 is able to go into 9. That is what we are taking. If there's a number that I can multiply with half for me to be able to get 2, that means half goes into 2. Hope that is making sense. So if there is a number that I can multiply with 2 for me to be able to get a squared, that means 2 goes into a squared. In other words, if you have got two numbers that you're going to multiply to be able to get a number, this means that these two numbers goes into what? Goes into the one that you are getting. This is the statement that I'm trying to bring out. So if you multiply 2 and b squared, you are going to get a squared. That means that 2 can go into a squared. Okay, so just here we're going to write a statement. This means, this is how you show if they ask you. This means a squared is divisible by 2. Now look, if I say 4 squared can be divided by 2, then this means that also 4 can be divided by 2. If I say 9 to the power 2 can be divided by 3, this means that also 9 can be divided by 3. So if a squared can be divided by 2, then a can also be divided by 2. So we are writing the statement still. This means a squared is divisible by 2, and so a is also divisible by 2. Hope we are following well. Now, if I say 4 is divisible by 2, this means if I say 2 into 4, I'm going to get a certain number 2. Now let's say I'm going to get a certain number x. let's just imagine we don't know it. So if 2 can go into 4, this means that there's a certain number that I can multiply with 2 for me to be able to get 4. This is the thing. So if 2 can go into A, there is a certain number that I can multiply with 2 for me to be able to get A. Okay, just a statement that I've written there. So we are going to say 2k is equal to A. Please, if you are behind, don't hide in the cloud. All right, and then from here, we are going to get back to this point. Where there is A, I'm going to substitute with 2k. So what are we going to get? We are going to get, where there is A, we'll put 2k. And remember that's A squared, so and that is going to be equal to 2b squared. And what is 2k squared? 2 squared, and then k squared, and this is going to be equal to 2b squared. Divide both sides. This is going to give us b squared being equal to 2 into 4, that is 2k squared. Now what does it mean? For us to be able to get b squared, we are multiplying k squared by 2. This means that b squared is divisible by 2. So if b squared is divisible by 2, b is also divisible by 2. Now, can you notice that are both divisible by 2? And from the start, we said that a and b are what? Primes. So this has violated our assumption. Therefore, square root of 2 cannot be right. It is not 2 do not have an intersection. So you need to make that statement at the end. Since a and b have got a common divisor, then a and b are not coprimes. Therefore, root 2 is not rational. I will not write that. Therefore, it is irrational. So that is how you show. It doesn't matter what you've been given, whether it is root 5, root 2, root 3, root 7, you use the same procedure. Any questions? All right.